welcome back to Having Fun Repairs. On this repair, we're going to take a look at a PlayStation 3 controller. This is one I've had for many years that needs a little bit of work done to it. There is an LED that's no longer illuminated. The charge port is pretty beat up. Certainly even some plastics missing. So we'll repair that, replace this charge board, and just play around with it a little bit, if I'm being honest. Because what I did is I went online and did a tad bit of research to find out what type of LEDs, mainly the size that board takes. There's plenty of information online about the PlayStation 3 controller from people doing different kind of light mods and stuff. And I figured I'd just go ahead and do one of my own with the official PlayStation colors, or close proximity thereof. We've got red, same as the O button. What color is this? Green for triangle, blue for the X, and I think one of these is supposed to be a purple or a pink. I'll just use it like a white or yellow, I don't know. But we're going to play with it and have 4 different color lights at least. Now, as far as the LEDs go, I'll bring them up. I think I got them off of Amazon. 100-piece LED strips come in super bright LED blue, red, white, green, orange, yellow. Color for flash LED diode, surface mounted device kit as described, and there's the size you want at the bottom of that description. 0603. Price was £3, 59p. And then the charge ports. What I did is I got something that I think would be a close facsimile of what is needed in here. So I got 10 times mini USB 5-pin socket female solder adapter connectors. 10 of them, £5, 49p. Have them delivered to my house, or at least my house for, I don't know, what month are we in? March, April, May, June. At least 3 more months, 2.5 really, because we are leaving, heading back to the States. So just so you know, I've got some video content lined up. I just need to get the videos rendered, etc. I'll get them uploaded to YouTube and scheduled out. But there will be a period of time where I'm not going to be able to make contents because everything in my house is going to be packed up and gone. And last time I had to move between continents, it was about 2 months, a month to 2 months for all my household goods and stuff to arrive. So we'll see what happens. Hopefully they're quicker than that, but I at least want to have enough content to where there's at least one video that publishes a month during that period. Just so y'all have something to watch for those of you who enjoy this channel. Anywho, we going to go ahead and take this guy apart. So let's do that next. Okay, so something interesting I'm seeing on this board. There's an LED right here, a LED 5, And then if you compare it to the front controller, sort of the PS button, that PS button you see right there by my thumb, fits over, and there's this little plasticky light pipe, rubberized light pipe that's kind of going there, but that thing has never illuminated. I'm wondering why. Maybe maybe that needs to be replaced too. Maybe we can do some testing on it, find out what's going on. Now that we got all this apart, it's a good time to do a quick comparison of our replacement USB parts. So you got 4 feet that feed through the side. These are more flush mount, and then you have 1, 2, 3, 4, 5 pins. These are all parallel. They're not really following the same path, so we're going to have to do some tiny bit of modification to this. And you can definitely tell from the top, if I can get it to focus. See how focus. See how rounded out that's gotten there. It's hard to tell with my camera. There's even a chip in the side over here. But this one, it's all nice and flush and flat right at the top. There's a good focal point. Let's see if I can do the same thing with this. It's definitely damaged. So we will make do as best as we can with that. It's not a like for like replacement, but if it wasn't a challenge, it would not be fun. Looking at the board, I think I could tell why this one's blown out. Really, we cut the light for a minute, see if that makes it better. It's probably going to just be too dark to see. I'm doing this work at night when everybody's already in the bed. This LED is substantially darker on its lens, right in the center. You might be able to tell that dark dot right there, which I think is indicative of an LED that's giving up the ghost. Let the magic smoke out, however you want to put it. The way we'll replace this, let's see. Your white markings are on the bottom side. So I'm fairly positive that the cathode is the bottom half, anode being the top half. So the top would be your positive rail, bottom would be your negative rail for this LED. These LEDs. So as far as coloring is going to go, we're going to leave that first one in since it's red. And then we'll go yellow, green, blue. Should be fairly easy to take these off. Yeah, those came off with relative ease. If you hear any in the background, that's just my air reflow station. I have it turned off and it's just blowing air to help cool it off quicker. But that's fine. You need to touch up these pads with a little bit fresh solder, and we'll put these other LEDs in. There we go. You can see that little green triangle. So I'm going to assume that the cathode is at the back side of this triangle and our anode is the other side. Let's go ahead and get the green out. Okay, and we'll test these again. Just because I like to verify and verify and verify billions and billions of times before I put something on board that I got it oriented the right way. Kill that light. Cathode should be on the left, anode on the right. Kill this light. And yellow. Hopefully you saw that. Do it one more time. Yellow. Here's green. Should be green. Nice pretty green. And our blue. Cool. Now we will get them soldered onto our board. Nothing too fancy about that. It's just the reverse of everything we previously did. Alright, so for this next part, we need to get the female end USB connector off. I'm going to do that by adding solder to these points and then pulling it away. I want to float them a little bit of leaded solder, so I'm going to go ahead and guess that this is a silver solder alloy. And that should help with the removal by adding in lead-based solder, lead tin-based solder alloy. So I'm going to set my soldering iron to 700 degrees and we'll just work through it, see what happens. Alright, so I think I've worked out what I'm going to do to get this onto the board. You notice the legs of the PlayStation 3 controller USB port are a lot longer than these ones are. They're also configured differently. If we said pin 1 on the left, pin 5 on the right, you see they make this W pattern underneath here. See if I can get this to focus on my finger. Or you go pin 1 upper left, pin 2 down, pin 3 upper middle, pin 4 down, pin 5 upper right. And there's significantly more length to them. I don't have this with this type connector, so what I've done is I've moved pin 2 and pin 4 straight down and made it as flat and as perpendicular as I can possibly make it with the bottom of this connector. You can kind of see those ones are a little bit shiny, so they're straight up. The other ones are still coming out. And then what I did, if you saw me, you're following along during the video speed up, is I put those two runs in here, and they are just barely peeking through the other side. So I'm thinking that I don't really like the idea of starting with those two, that I will start with those two and get them soldered in, and then I'll just flush mount, keep all the rest of them flush, as in if this was a surface mounted USB versus through hole, and see if I can't get it attached to the board that way, and hopefully it works. Hopefully. We will find out though. Alright, as best as I can tell, there is continuity from this side of the board to this side of the board as far as those pins go. So I think it's going to work. And then what you saw me do is also test each ground point to its other ground point. So if I did a continuity test here and then checked each one of these three pins, it's safe to say that they have made a good connection to the other side of the board, because you'd have to go through the board chassis of this USB connector to that pin over there for full continuity. So next thing I want to do is figure out what's going on with this dude right here. I think we're going to have to quasi put this back together a little bit. I'm going to put it back together a little bit and do some testing, so hold with me for a second. So I was poking around this board a bit with my multimeter, and I put things somewhat back together, and was just trying to figure out where these two pads go to. Now, I was able to determine, and maybe I'll zoom in just a smidge here. Too far. Let's back it up. Right there seems to be about optimum. That I am getting a DC voltage to this left pad here. This one should be your cathode side, essentially going to ground. Now, compared with these others, other LEDs, and it's not a direct short to ground, there is some resistance there. And so I said, okay, well, if you notice I took that LED off, if there's voltage here, then why is it not illuminating? So I traced this out, went over to where you see R22 right here, and this little pin, followed it through and back around, and then it ends up coming to this little test point here, and these two pads right here, which you see that there's nothing populated between here. So that tells me that maybe this was a function originally designed for the controller, but was just removed prior to production or something. But what I'd like to do is replace it with this little white LED right here. So I'm going to solder this into place, and then, now it might blow it up, but I'm going to short with my tweezers between these two pads right here. Sorry if you didn't see that LED. There goes a little white LED. I'm going to put a white one there. Tell by the size of my finger just how small this thing is. Really small. But I'm going to use my reflow station, hot air reflow station, and solder it into there, and then try powering it up again, and briefly short out between these two pads. Now what I think needs to go there is a resistor. Could also be a capacitor. I'm not too sure, if I'm being honest. But by shortening out between these two pads, at least there is a connection, and we'll see an electrical connection, and we'll see if this right here at least illuminates for a second, or if it's going to blow out. I'm slightly concerned about putting heat on that side of the board with this IC on the other side. As the board was flexing, I was hearing some things and wanted to go back through and just make sure that all those connections were still to the board. Everything's plugged in. I'm going to touch the battery. Little prelude, you see those lights are working just fine. That one is not. So what happens if I short out? Those two pins right there. Still nothing happening. So, well, I have to believe that it's the correct voltage feeding into that LED. Let me think for a second. Was that voltage constant, or does it disappear? I presume that LED has a current limiting resistor in line. Again, big assumption. But when push comes to shove, we can just run one wire to ground. I think pins 7 and 5 are both ground. They are. Okay. Let's get those lights flickering again. We have 2.7 volts, and I highly suspect it to be below 3 volts for these diodes. these type of light emitting diodes. So will it disappear? Because I don't want to tie this directly to ground, the other side of that LED, if it's just always going to be on, because that's going to kill battery life. It's probably boring, but it is always there. Alright, so I've done a bit more poking and prodding around, and I actually found a bit of information about this chip right here, because everything leads back to this IC. And that IC is definitely driving those LEDs. Then I was able to pull up a schematic on it. There's a Toshiba T6UN 6 EFG. Was this one a 6 EFG? T6UM 3 EFG. I need to find the 3 EFG. Oh, it's all got the same pin out regardless. But anyways, okay. So hopefully this diagram is correct. And when you look on here, pins 23, 24, 25, and 26 are your LEDs led through a 4 times resistor network. And then it says that the actual LED, oh no, it appears that the resistor network is probably on the board. Pin 27 is not connected. There's question marks for PS button backlight, LED, and prototype. So I'm hoping potentially that that's it, and I don't break this controller, because what I'm about to show you is that when you count over, here goes pin 1 up here in the top left corner. Ignore some of this overspray I got on it with the either flux or alcohol. But there goes pin 1. It's in this upper left hand corner. You can see the dot on the board there. You can follow it down 20 pins across each side. So you got 20, 40, 60, 80. So pin 27 is going to be down here. 1, 2, 3, 4, 5, 6, 7. And then pin 7 actually runs to this little test point right here, TP51. And just to show you that, for the continuity test, here's some loud beeping. Beep, 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 beep. I'm going to go to test point 51 and just run it across the board. It's pin 1, 2, 3, 4, 5, 6, 7. Alright, so with that determined, I think what I'm going to do is using this little piece of wire right here, so I'm going to solder to that test point and to the other side of the LED, and we're going to see what happens. Well, if you can't tell, it's always on. So unfortunately, I don't think that's going to work. I have to find out another way around this. not want an always on LED. Figure out some way around this. Sit back and think about it for a while, and then come back to it. Okay. I've been poking around this board for hours. And it is 3:37 a.m. But I finally have a solution for this LED. At least one that I like. Right now, this is, I'm going to go over what I discovered and how I've hooked it up, but I'm going to wait till tomorrow to actually get this, to make this look good and put everything back together, because it's just too late at night. But anyways, so what I did is I was poking around my multimeter on what basically looks like small little voltage regulators on this board. Let me disconnect the battery. And this guy right here real quick. Okay. So I can bring this a little bit higher up. Can't really make out the words on them, but they say PONA and C28-4K, I think. And I'm pretty sure these are some type of voltage regulator. And what I determined is the upper leg on this one outputs 2.8 volts, which is what we need to drive an LED. Now mind you, there's 2.8 volts already driving the anode, biasing the anode of this LED. But what I decided to do was to take a diode, a little switching diode. What type of diode is this? 1N4148, 200 milliamp, 100 volt rated switching diode. And I tied the anode to that 2.8 volt output. Now it's not always there, it's only there when you push the button and a signal is sent to liven up this circuit. It's not always on. I don't know exactly everything it goes to, but hopefully under play that light remains on so long as the controller hasn't shut itself off. But anyways, anode out to our switching diode, cathode to the base of an, what is this, an S 8050 NPN transistor. NPN meaning you need a positive polarity to bias the transistor in order for electrons to go, or electrons to go from collector to emitter. But anyways, on the collector side of this transistor, so you have it temporarily soldered into the anode of that LED there, and then on the emitter side it is tied to this ground rail here. Now, like I said, this is not going to fit in the controller. I'm going to have to mock it up a wee bit, shrink everything down, make it look all nice and pretty. Actually, let me put that ribbon cable in before hooking up the battery. But I think this is going to work. Now I've seen other things on base. Not on base. Now I've seen other things online saying how to set up this diode, running a bunch of wires and stuff. I really didn't want to do that. I kind of just wanted to find my way around my own solution. You see, when you first plug that battery in, the LED lights up for a brief second. And there's like a quasi-wake function on this board, or maybe that voltage regulator just ramps up for a second. But anyhow, see, lights are on, LED is on. And I'll turn off this light, this one up here. You'll see when those LEDs go out, the flashing ones, so does the one on the board. It's pretty cool. I like it. Now we're no longer draining the life of that battery with, you know, some small LEDs. Look, this little battery will probably power that LED for days and days and days and days and days, but that's not the point. I do not want an LED that's always on. So, this is where I've gotten to, and I'm going to call it quits for tonight, clean up a little bit, and re-attack this in the morning. So see you when it's daylight. Okay, now that I've gotten some rest, I can get back to this. And I drew up a little circuit diagram for everybody. You can see that the, again, I believe this is a voltage regulator. U4 is how it's labeled on the board right here. And you can see that we have the anode of that 1N4148 switching diode soldered to it, cathode out to the base of the S8050 NPN transistor, then output to pin 7 of J5 over here, and then the cathode of the LED tied to the collector of this transistor. Now the reason why I wanted to include this is I started thinking about, well, what if this NPN happens to go bad, right? So if the base ever shorts out to the collector, I want to provide some type of protection between this voltage source and the 2.8 volts DC that could potentially come through this way. This should reverse bias this diode, so that way nothing is ever connected in the event of a fault. I'm hoping that's how it will work. You know, it really doesn't offer any protection. So say if you short base to emitter, then that 2.8 volts is going to be allowed to go to ground. Would have been nice to have some type of fuse here. I don't have any in stock. Definitely don't. Well, I have fuses, but nothing small enough to fit on this PCB. In the event that occurred, that fuse could blow, and then that's going to completely isolate this circuit. But anyways, so now it's going to be making this thing fit onto the PCB in a nice way that all the pieces and components can go together in a good fashion. So that's what we're wanting to do next. Well, just so I can show a mistake, I thought I had cleared the bottom part of this. I did not, and so I broke the leg off of this transistor here, going from the emitter to the ground. So I need to move this up quite a bit and restart this again. But you've seen the process, so I'm not going to repeat it in video recording. I'm just going to do it off camera and then show you the final product. Okay, so I have this moved over to this side now. That's well out of the way, so it's just going to be piecing it all back together. Alright, got it all back together, and let's test it out. That's illuminated. Those are illuminated. It's pretty cool. See if it times out. I like it. It's really cool. I'm going to plug it up to the PlayStation to make sure that it can still sync and work. Okay. PS button still works. LED's illuminating. See if it syncs. Syncs wirelessly. And it went to 2. See what that means. See if it will switch to 1. It's probably because I already have a PlayStation 4 controller plugged into here, so let's unplug that for a second. Try it again. It says the battery is low. That's fine. So let's see if it charges. Hold on a second while I plug in the cable. Alright, charging appears to work just fine. See if I can get that little icon to pop up. Yep, there we go. Now I'm going to reassign to cycle through the LEDs. See, settings, accessories, reassign controller. Yeah, that's what it was. Alright, there we go. Reassigned to 1. Let's try 2. Okay, switched over. Let's try 3. 3 is there. And let's try 4. 4 is working, and this stays illuminated. Let's reassign this to 1. Alright. And I'll load up a game and make sure all the buttons work as they should. Oh, we got a dodgy cable.
We got Black Honda.
Alright, switch games because I'm not quite sure what R1 and R2 do in that last one. But there goes R1 cycling different things.
That does it shoot?
Oh. Everything appears to be working just fine, as it should.
Daddy says shoot.
Drive. Boost.
Daddy, can it shoot? Daddy, can it shoot?
Yeah, it sure can. Machine gun.
Daddy, what's the
Special cycle that way.
Daddy, what's the shoot?
Analog sticks still seem to be working fine.
Daddy.
Left, right, forward,
Backwards.
reverse.
Oh,
Cool.
monster truck. Daddy.
I like it. Well, ladies and gentlemen, if you like that video, a little brief couple of minor repairs on the board and some modifications. You know, like it with a big old thumbs up. Subscribe to the channel if you want to, and feel free to share the video. I'm going to provide the little diagram on my Google site. Link will be in the description down below. But anyways, take care. Bye. Okay, folks, I don't like leaving things, especially after a week of testing. I noticed some issues with the circuit and the design. I think U4 has something to do with charging of the battery. And maybe this 2.8 provides that trickle charge out, but I did know even though I'm getting a charging signal, it's taking way too long to charge the battery. It's not, the controller won't stay charged or stay on. So I redesigned the circuit a little bit. Instead, what I've done is I've tied that diode to TP51 from the other side of the board, which coincided with pin 27 from this IC. I believe was the pin for the LED light to begin with. And so that is a new diagram, and that is what I'll provide up on my site. Now, I have tested this out for several hours on battery and charging, and it has not died since. And as you can tell, that light is still working. So this will be the final design. I know that I said the last one was the final design, and I do apologize, but this will be the final design for your PS3 controller, at least for my purview with a 5th LED. I didn't want to leave those things unsaid and send somebody down the wrong path and having more issues with their controller. So please forgive me for that. And you know, if you still like the video, give it a thumbs up. Thank you.